know you're all just dying to learn about my newest experience. My 5-year-old grandson loves the Cars movies, and in one of the Cars movies, there's a demolition derby, you know, with Miss Fritter and all that, okay? So at the state fair last night, I went to the demolition derby with my little grandson. That was quite an experience, and it was hot. But luckily, I'm used to that being in this room, so that part didn't bother me as much. But it's loud, and they just crash into each other. Have you ever been there to a demolition derby? They just crash into. The whole point of the whole thing is last guy standing, or running, or moving, or something. Anyway, it was interesting. All right, solve by factoring. A little quadratic. All of us can do this, right? We're not gonna worry, we're gonna just jump in and kind of trial and error it. And we're thinking in our head as we're going that if I FOIL out what I think my factors are, I should get my original problem. And I think I'm good. I think I hit on it here. Is that okay with everyone? And of course the directions were to solve by factoring. So now I can use my zero product property, set these equal to 0. So it looks like I'm going to get negative 1/2 and 2. Easy enough. Now we're going to factor the one you just graphed. So remember, if you're factoring, you got to be set equal to 0. And the first step in any factoring problem, now it wasn't applicable over here, but the first step is always to check for a GCF, a greatest common factor. Do I have one in this problem? Yep, 3x. And I'll be left with x squared minus 4. What do we call x squared minus 4?
The difference of squares.
Difference of squares, and it factors as, in this case, x plus 2x minus 2. And then here come your answers. X equals 0, x equals negative 2, or x equals 2. That's what you got graphically, that's what we get by factoring, that's what we're always going to get because those are the answers. Number 5, solve by extracting square roots. That's what they call it when you simply square root both sides. If you found that out in the hallway, would it occur to you to just square root both sides to solve it? So the square root of 4x squared is 2x. And the square root of 25 is, be careful, plus or minus 5. When you put the square root into the problem, when it wasn't in the original, I put it in, you gotta include the plus or minus. If you just find an equation and it already has a square root in it, then it is, in this case, the positive square root. If it wanted to be negative, it becomes negative. But if you put in the radical, it's gotta be plus or minus.
But you don't have to do it on both sides, right? Just
No,
one side.
because that would cancel out Will. Let me finish this. So x equals plus or minus 5/2. Now Will says, technically, shouldn't I have a plus or minus over here also? And the answer is yes, but look at what happens. This would be 4 equations. This would say positive 2x equals positive 5. Positive 2x equals negative 5. Negative 2x equals positive 5, and negative 2x equals negative 5. See what happens? Yeah. So you really only need it on one side or the other. I just habitually put it over here, but it just goes on one side or the other. All right, we good with that? All right, now we're, in case you haven't noticed, we're solving quadratics a whole bunch of different ways. So now we're going to complete the square. This is no one's favorite, but too bad. It's how we got the quadratic formula, so we need to know how to do it. So who remembers the steps to completing the square? Charlie?
You like take the 4 and then add it across the 0.
Yep,
so
that's exactly right. So he says, move that 4 to the other side. Right, then what, Charlie? You remember?
Then you take the 10x and you divide it by 2 and square it.
So we take half of the 10, right? We're finding a number now. So half of 10 is 5 squared is 25. And why did we do that, Charlie?
Because it's a perfect square now.
That's a perfect square. Your goal, that's why it's called completing the square, was to make this a square. So you just did it. And then it looks just like this problem right here again. You can square root. Obviously, the square root of something squared, those are going to cancel. And over here, plus or minus root 29. So x is negative 5 plus or minus root 29. These are called the exact answers. If you were to graph this on your calculator, you would get weirdo decimals, right? Those would not be exact. They would be approximations. These are the exact answers. Okay, and that'll be obvious when you take your AP exam because you're either gonna have a no calculator solve or you're gonna have a with calculator solve. All right, how about B, 6B? This one looks a little bit different right from the get-go. Does anybody remember what we have to do with him?
Divide out the 3.
Divide by 3. We have to divide everything by 3. And that is going to be slightly uncomfortable because we're going to be left with some fractions. I copied my problem right now. That's okay. We're going to do everything the same. So first, we'll move the 7/3 to the other side. Where's your lanyard? How do we figure out what we're going to add here? We have to add something to both sides. How do we do that again? Half, divide by 2. When it's a fraction, I'd rather just take half, but it's up to you completely. Divide by 2, take half. So half of 2/3 is 1/3. And then I gotta square it, so I get 1/9. It's not pleasant, but it's doable, you got it. So what square do I have? X minus 1/3, very good. And now I gotta add these. Did you get 22/9? And then we'll square root. So x minus 1/3 equals plus or minus the square root of 22 over 3. And we'll add our 1/3 over. And either write them separately or together since they have a common denominator. I put them together, is that all right? You can write them separately also. Okay. calculators back at. Let's look at these equations. We're gonna solve these, thank goodness, graphically, because otherwise it would be kind of a pain in the rear end. I loaned my calculator out last period, so I'm gonna Zoom 6, so I have some kind of standard window. And now I'm gonna put in my equation. Anybody know where we find the absolute value? In math, yep, go to your math button, and then over to number, and it's number 1 right there, absolute value. And then type in 2x minus 3. I'm gonna do intersections, so I'm gonna leave this as y1, and then for y2, I'll put in x squared. You don't have to do that. But if you're gonna put it on one equation, you're gonna have to subtract 1 to the other side. All right, I'm gonna hit graph. How many points of intersection do you have? 2? All right, let's find them. If you're having any trouble with your calculator at all, lean over to your neighbor. Have your neighbor help you. Or find a neighbor that can help you. Remember that we are looking for x, we're solving for x. This worked out way better than I thought it was going to. How'd you do? Were you able to find both points of intersection? What were your x coordinates? I know I forgot. Was it -3 and +1? Everybody good? All right, try the next one. Remember, at least 3 decimal places. What'd you come up with? Anybody got them? Will?
I got -1.638 and 1.447.
What I got? Does that sound okay to everybody? Good with that? Alright, almost done, here we go. Solve with the quadratic formula. Alright, so we solved by taking square roots, we solved by graphing, we completed the square, now we're gonna use the quadratic formula, which, by the way, only works with quadratic equations, right? So don't try to do it with something else. It won't work. Who remembers the quadratic formula? Lily?
Opposite would be plus or minus square root of b squared minus 4ac over 2a.
All over 2a, right? The whole shebang is over 2a. And of course, a is your coefficient on your x squared, b is your negative 2, and c is your negative 7. We derived that the other day. Went through and actually figured out where it came from. Now we're going to use it. So one more time. 2. Stop me if I mess up. Don't let me keep going down the wrong path. Does that look okay? Remember, when you cancel in an expression like this, you have to be able to cancel out of all 3 positions. So if we had 2 plus or minus 3 root 22, you would not be able to cancel. It has to be all of your spots. Okay. All right, one more. Number 9. See if we can figure out what's going on there. Ideas.
You could use diagonal theorem and the missing side there would be x plus 5.
Parker says this is x plus 5. Would you agree with that? And then he said, I got a right triangle, so I can always use my Pythagorean theorem. What is 18 squared? 324. Does that look okay? Everybody? FOIL. FOIL right here. Please, please, please don't get crazy. That's a FOIL. 2x squared plus 10x. Is that minus 299 equals 0? Don't finish that. Yuck, yuck, yuck. All right, thank goodness we have a calculator. We can divide divide by 2, I wouldn't if I'm gonna use the quadratic formula. If I'm gonna complete the square, I have to divide by 2, but since that's just gonna put some fractions in, I think I'll just leave it alone. So here we go. Let's go ahead and use our calculator to get a decimal approximation. What happens, in this problem? Two answers, but what about one of them? One of the answers is negative, so it's extraneous, we throw it out. Be careful. First of all, is that right? 9.980. Now what's that? That's this. So what's the answer to the question? Bad 5. So the actual answer to the question, how far up does the ladder reach, is 14.980 feet. Is that okay? All right. One thing I forgot or didn't do, someone even asked me about it and I just blew through it, is I want to go back to do one more thing with statistics, and then we're gonna start P6. Tomorrow we'll do a little review of P1, P5. P5 homework is due on Wednesday. Tomorrow we'll do a little review, and then the class after that, we'll have a P1 to P5 quiz, okay? But in the meantime, we're starting P6, but there's one thing I want to come back to on the calculator. Do you still have, go to Stat, Edit, and do you still have that data in from that one problem that we did where we put numbers into our calculator? No. All right, then let's start. Let's just make up some numbers here. Let's just start with some data. So L1, L2, these are ordered pairs. We'll just say 1, 2, 3, 4, 5. And we'll do 3, 1, 5, 7, 8. So let's put in these ordered pairs, this L1 and L2. Remember, if you need to clear out a column, highlight the column name. So highlight L2, hit clear and enter, and it'll be gone. And then you put in your names. Alright, now we're going to do a linear regression with this, but don't get going too fast, okay? So go to Stat Calc. We're doing a linear regression, so we're choosing the option AX plus B. Now, at this point, we're going to diverge a bit. If you have a new calculator, alright, because we are not only going to get the equation line, but we're going to have our calculator graph the line. Okay, so what we're going to do, if you have a new calculator, if you're one of these, just hang on, I'm going to show you in a minute. Gilroy Beach. You're gonna click down to where it says store regression equation. All right? And then you're gonna hit your variables button. You're gonna go over to Y bars, Y variables, hit function, choose function, and then Y sub 1. So now where it says store regression equation, it should say Y sub 1, right? Then you go ahead and go down to calculate and hit enter. Now, absolutely nothing looks different, but now if you press Y equals, you will have that equation entered there. So now when you hit graph, it will graph that equation for you, okay? Without you having to type it in and round it off. If you have an old one, okay? So you have chosen, does anybody in here even have an old one? Am I the only one with an old one? Okay. Is he the only one with an old one? Got 2 old ones? All right, I'm gonna give another set of points. You two come up and I'll work with you two individually, okay? Hang on. Here's another set. I want everybody to practice this while I'm working with them. New data point. Completely random. I have absolutely no idea how that's going to look, but go ahead and put in those data points. If you have an old calculator, come over here, and I'm going to help you with the old one. Okay, so you've done, is your data points in? So when the second quit, go back to stat, over to cal, and choose linear regression. Oh, you have a new one. So yours is, you're like mine. Okay, so you did the same thing they did. So you go down to bars. Okay, so what we have to do is, we have to put second L1, and then comma. So here's L1, so second L1, and your comma. It's right there. And then second L2, comma. And then we go to bars. Click over to Y. The function. So now yours is going to say L1, L2, Y1. Okay? And then you come up with the stats. And then when you get Y equals, well, I got it. I must have learned it from last time, but right there it is. There's your 2. So you've got the ones 2 in there, 2 in there. And then if you have to graph that equation, you can graph it. Okay? They're all very Just,
If I get a good sleep on it, then I'm here.
all right, so we get an equation for this one. I didn't type in, what did you get for this mess of points here? Y equals what? Did you get point? What's your equation? 0.773x. Guys, it's right there, right in front of you. Negative point. So 0.773x minus 0.333. Perfect. And if you had to graph it, you type in, you store that regression equation as y1. So then, as soon as you hit y equal, or as soon as you hit graph, it's going to graph y1. And it's going to graph that for you. All right, I just wanted to touch base on that before we got started. Tomorrow, tomorrow, we have some homework things we need to look at, but I really encourage you to get your homework questions taken care of during office hours. Some of you have been coming in, and that's great, because we just don't have a ton of time to go over individual homework questions. All right, P6, here we go. All about complex numbers. What are complex numbers again? Anything in the form A plus BI, where A and B are real and I is the imaginary unit. So, what would make two complex numbers equal to each other? What would have to be the case if those guys were gonna be equal? Don't make it hard. It's really obvious.
A equals C and B equals D.
If and only if, you've seen that before in geometry, A equals C and B equals D. Anybody, you've heard that word conjugate before. Anybody know what it means to be a conjugate? You've done it a lot, so think about when you had when you were solving something or simplifying something, and you got 3 over 2 plus root 5. Your teacher didn't want you to write that in the answer blank. What did you do to that to make that acceptable? Violet?
Multiplied by 2 minus root 5.
And that's the conjugate. That's the conjugate. And the reason that you did that was because when you FOILed, the radical went away. And this just became -1 down there, 4 minus 5. So the conjugate, if Z, I had to give it a name. The textbook calls it Z, or call it Z. If Z is A plus BI, then the conjugate of Z, which is written like that, is A minus BI. I figured you've done more work with radical expressions than with I expressions, but it's the same idea. If you're starting with A plus BI, then your conjugate is A minus BI. And then sometimes with complex numbers, we run into powers of I. This is what we mean by powers of I. So I refers to just I, and that's the square root of -1. We know that. That's the definition of I. What happens then when you square that? What is I squared? -1. When you cube it, that would be the same as I squared times I. So that would be -1 times I. And when you fourth it, that's like I squared times I squared, which would be 1. And then what happens if you keep going? Like, what about I to the 4th? What happens with that? It restarts the cycle because I to the 4th is just 1. So every I to the 4th, I hate to say cancels out, but it's just 1, right? 1 times 1 times 1. Okay. Let's simplify then. Here we go. Now remember, this stuff is review stuff. We're heading toward taking these crazy complex numbers and graphing them, finding their square root, taking them to powers, doing all kinds of cool stuff. Right now, just the basics. Here are these random numbers I just made up. What is the first one plus the second one? What do you think that would equal? Yep. I'm not sure if Violet's the only one awake. I know it's hot in here. We have a lot to do. All right, Z1 minus 2Z sub 2. Let's see, I'm gonna call on someone. Miss Jackson, what do you think we do with this one? You don't have to do it all at once. You can do it in pieces. What do you think?
You plug in 1 to 4, so 2 plus 3i minus
distribute there, and that's actually a -2, so it'll be -6 plus 10i. And in right terms, so -4 plus 13i, is that look all right to everybody? Livia, what do you think about this next one? This is a multiplication problem. So what do you think we ought to do first?
Plug in a Z1 and Z2.
Yeah, I'm plugging in my numbers here, so I got my numbers plugged in. So then what?
Distribute 3.
So 6 plus 9i. And then I'm multiplying that by 3 minus 5i. Miss Cress, what do you think? She's right so far. What do you think we should do now?
Foil the 2.
So I'm gonna get 18 minus 30i. Oh, don't yawn. 27i minus 45i squared. These two are gonna make minus 3i. What about that guy? He's a positive 45 because I squared is -1, which is gonna make this a 63 if I add it right. Alright, one more that I'm gonna set you loose because I'm already together here, this division problem. And I'm gonna set you loose to do a few of these other ones. Alright, so now we're divided. Evan, what do you think?
I multiplied by the conjugate.
Yep. And what would the conjugate be?
For Z2, conjugate would be 3 plus 5i.
Exactly, we're gonna multiply top and bottom by 3 plus 5i, so we're just gonna have a couple of foils to do. And Evan, the goal, your purpose, was to make this I disappear. So let's see if you did it. I think you did. I think your denominator is just 34. I don't know what that is. Do you have an alarm set for 10:30?
I don't know why it keeps happening on my alarm app. It's like it'll be like random days.
I got -9 plus 19i, but that could be wrong. Is that okay with everybody? All right, part 3. We got we actually have 4 problems in part 3. So let's see if you can do these and get them up here on the board. It's gonna be kind of squishy to get all 4 of them up here. In fact, we're only gonna do the first 3 to start with, because we only have room. So if you and or your partner have an idea, in letter C, that I is not under that radical. I got kind of sloppy, we're not ready for that yet. You will be able to handle that eventually, but that is outside the radical. Okay, I'm ready for volunteers. I'm dashing out. I use 35 fours, but that's the same as 8 3/4, so that's fine.
But do you know if you bring the eyes out first?
I totally love what Charlie did. He did it exactly right. When you have a negative radicand, a negative number under the radical, the first step has to be to pull out the I. So I know you're tempted to multiply the -3 and the -8, but you can't. You gotta pull out the I's first. What difference does that make? It makes his answer negative. The answer is negative. So he is perfect. Good work. Good work. Okay, nobody's tackling that last one. Don't be afraid. It's not a multiply, it's just a subtraction. Okay. Mr. Funk, head to the board. Now that you've got us all weak with your keyboard thing, come on up
Okay.
and I'm gonna help you.
Okay, good. I'll need it.
So remember, we're not foiling, we don't get excited, we're just collecting right terms. So we got √7, right?
Yeah.
And then what?
And
Look in
then-
the first parenthesis, let's just do one parenthesis at a time. So we have √7, and then what's that from?
It's -1.
Okay, so write down √7 minus 1. Okay, now why don't we go ahead and distribute in this next one? So that'll be -6 plus square root of -8, or pull that I out, that I isn't under there.
Oh, okay.
Okay, now what do we do with the square root of -8?
You take the 2 and the I out.
Okay, so go ahead and do that. other part too. So you still have the root 7 minus 1. And now you're gonna combine whatever you, okay, what happened to the I at the end?
Oh. Yeah.
Okay, so now before let's look at that last term. What can you do with that last term? You have a 2, root 2, and then I squared. You have the I in front of the radical,
Yeah.
and you have the I at the end
Oh,
of the radical.
okay.
And it's all being multiplied.
So, yeah.
Okay, write down the rest of it. And will any of that combine?
These two.
Okay,
Can you do anything else?
nope,
Okay.
I think that's your answer. Know what I got? Yep. So that wasn't so bad, was it?
No.
You did a good job. Thank you. Anybody have a question about anything that the kids did on the morning? Good? All right. Do you have time for this question? Probably not. I'm gonna stop there and we will pick up here next time. And we will review next time a little bit. And here's, last call for math league money, we're all good? Everybody signed up, it's gone?
Yeah.